preparing to this lecture, I saw a really good comparison. So, for example, as you know, nervous system nerves just travel in one direction from one neuron to another onto another neuron. So basically, they go in one direction. And so my analogy is, it's like email. You see, when you send one email from one person to another, or they send from one person to another, that's like nervous system. It goes really fast and it's gonna target a specific cell. And when do we use the nervous system? Want to do something really quick. So if somebody were to throw something at me and I were to dodge it, that would be my nervous system that is acting. So, but we are talking about endocrine system. Endocrine system is more like Facebook. If I were to post to my Facebook status update that I'm, for example, working on a cell communication podcast by myself, there is gonna be a delay. There is going to be a time before other people look at it and dislike or like or respond to it. And that's going to be more like the endocrine system. I'm sending it out to everybody, and whoever wants to respond to it can. And so I think you should keep that in your back of mind. So endocrine system includes the endocrine glands and their hormones. The function of the endocrine system is to secrete hormones into the bloodstream. Hormone is a chemical messenger which targets a specific group of cells in order to cause that group of cells to do some activity or stop doing an activity. So like or dislike. First of all, anything that is going to send out the messenger of endocrine system is called, as I already said, a gland. And we'll go over some important glands. The chemical that they send out is called a hormone. And then it's going to target cells or not. It may target certain cells or it may not target certain cells. And so we could send, for example, follicular stimulating hormone, the pituitary. It's only going to affect ovaries and the testes. But if we send out growth hormone, that is going to affect all the cells in our body. So what do these hormones do? They simply diffuse throughout your body. They're going to spread throughout your body and bump into cells or not. They're going now then they find cells. They can do one of the two things. One of the two things can happen. If they are water-soluble hormone, an example could be epinephrine or adrenaline. They're water-soluble. Basically, what they're going to do is they're going to dock with a protein on the surfaces of their cell. Since they're water-soluble, they can't gain entry to the cell. This is really important. And so usually what they'll do is they'll set up some kind of signal transduction pathway to have some kind of an action out here, or have nucleus where we could make certain specific genes or certain proteins transcribe certain genes. That would be water soluble. But we also have what are called lipid soluble. For example, testosterones. Basically, since it's lipid soluble, it's going to move right through that lipid bilayer that is the cell membrane, and it also can target with the cell and move right into the nucleus, because again there is going to be a lipid bilayer here as well. And so lipid soluble hormones are going to move all the way into the cell. Water soluble are just going to dock with the receptor protein on the surface. So what's the difference between exocrine and endocrine glands? Exocrine glands release the secretion into ducts, for example liver or pancreas. Endocrine glands are called ductless glands, release hormones directly into the bloodstream. Blood transports hormones throughout the body. Each hormone acts on only certain kinds of tissue called its target tissue. Here, as we already said, each hormone acts on. So here are some of the human endocrine glands: pituitary, thyroid, parathyroid, adrenal, pancreas, testes, and ovaries. Pituitary. Pituitary gland is a round organ about the size of a pea, 1 centimeter in diameter, located behind the bridge of the nose at the base of the brain. Secretes 9 different hormones which affect many different areas of the body, including growth, blood pressure, regulation of pregnancy, breast milk production, sex organ functions in both men and women, thyroid gland function, metabolism, water regulation in the body, kidneys, temperature regulation. I want to say that, as you know, the hypothalamus is kind of the connection between the brain and endocrine system. So it can secrete as well, but we are going to say it's influencing the pituitary. Pituitary, also called hypophyse. So hypophyse basically has 2 lobes: the anterior, that means towards the front or towards the head, and the posterior is going to be towards your rear end. For example, anterior hypophyse gives off growth hormone. It gives off a number of the other things like follicle stimulating hormone and endorphins and so on. But we're going to talk about growth hormone, which again is going to float throughout the rest of your body. It can do that in the circulatory system, or through the interstitial fluid, and basically it's going to cause the cells of growth. And the thyroid stimulating hormone to stimulate the thyroid to produce thyroxine. Follicle stimulating hormone regulate puberty, development, and reproductive processes. Luteinizing hormone stimulates the product of estrogen and testosterone. As you see, growth hormone, oversecretion of growth hormone, can cause giantism in childhood and acromegaly in adults. Bones of face, hands, and feet enlarge, as you see in pictures. Undersecretion of growth hormone can cause dwarfism in childhood. Here. Thyroid. Thyroid located in the neck releases hormone thyroxine. Function is to regulate rates of metabolism in the body, essential for normal physical and mental development. Oversecretion of thyroxine can cause results in nervousness and weight loss. Undersecretion of thyroxine results in cretinism, mental retardation, small size in children. As you see, what can cause? Parathyroid. Function is to control metabolism of calcium, necessary for normal nerve and muscle function, blood clotting, healthy bones and teeth. I hope so. I hope one of the students is gonna make a referat about this, because there's the role of calcium is huge. Located in back of thyroid gland in neck, hormone releases in parathyroid. Undersecretion of parathyroid results in nerve disorders, brittle bones, and clotting problems. Adrenal glands, kidney heads. located at the top of each kidney. Here we are. Hormones releases are cortisol and adrenaline. Function of cortisol is to regulate carbohydrate, protein, and fat metabolism. Promotes conversion of fats and proteins to glucose. Function of adrenaline is to raise blood sugar levels and increases heartbeat and breathing rates. Here. Islet of Langerhans. Located on the pancreas, hormones secreted are insulin and glucagon. Insulin stimulates glucose up by cells. Glucagon promotes conversion of glucagon, animal-based carbohydrate, to glucose. Blood sugar regulation. Oversecretion of insulin results in low blood sugar. Level of blood sugar. It's important. Undersecretion of insulin results in high blood sugar. This can lead to a condition known as diabetes. Diabetes type 1. Type 1 usually found in children and young adults. The body doesn't make enough insulin. Symptoms: frequent urination, unusual thirst, extreme hunger, unusual weight loss, extreme fatigue, and irritability. Here we are. Diabetes type 2. Either the body doesn't produce enough insulin or the cells ignore it. If you consume too much sugar over a long period of time, your blood has to release large amounts of insulin. This can result in your cells building up a tolerance for insulin, which means they won't be affected by it. Symptoms: any of the first type, as we already said. Frequent infections, blurred vision, cuts, bruises that are slow to heal, tingling, numbness in the hand, recurring skin, gum, or bladder infection. Here's diabetes type 2. Mechanisms. Negative feedback mechanisms act like a thermostat in a home. As the temperature cools, the thermostat detects the change and triggers the furnace to turn on and warm the house. Once the temperature reaches its thermostat setting, the furnace turns off. Example: body sugar increases after a meal, so the pancreas secretes insulin, which tells the body cells to take in glucose. Once blood sugar levels reach normal, the pancreas stops making insulin, often used to maintain homeostasis. Negative feedback. Homeostasis is often maintained by two hormones who have antagonist effects. Each hormone does the opposite of the other. As you know, antagonist, what is it? For example, if the blood pressure drops too low, the pituitary releases ADH, which causes the kidneys to reabsorb more water. If the blood pressure increases too much, then the heart will release NH, which will cause the kidneys to reabsorb less water. And positive feedback mechanisms. Positive feedback mechanisms control events that can be out of control and do not require continuous adjustment, rarely used to maintain homeostasis. Example of positive feedback found in childbirth. Oxytocin stimulates and induces labor contractions. As labor continues, more oxytocin is produced. Intensifies contractions until the baby is outside birth canal. Oxytocin production stops and labor contractions stop.